Today we're going to be looking at rounding off decimals and also looking at how to write a repeating decimal in a shorter way. Firstly, we're going to have a look at the whole idea of rounding off numbers, similar to what we did back in chapter 2, where we were required to round off in order to estimate the value of numbers. So let's have a look at 7,469, and we're about to round that off to the nearest thousand. So if we want things rounded off to the nearest thousand, then our job is to look at the value of the number that is in the next column, in this case, in the hundreds column. We look at that number and we use this guide down here to decide whether it is a number that is big enough, 5, 6, 7, 8 or 9, to warrant going up to the next thousand, or whether it is a small number, 0, 1, 2, 3, 4, like it is in this case, a 4, and where we round down, and where we say that this is approximately equal to, remember those squiggly equal signs, 7,000. So let's go through that again. We look at the number that's to the right of the thousands column. If it is a 5 or bigger, we would turn it into an 8,000. But if it's a 0 through to a 4, then we leave it as 7,000. Okay, so let's have a look now at what happens when we're looking at decimal numbers. We're going to be asked today to round the following numbers to 2 decimal places. This means we want to keep only 2 numbers after the decimal point. And as you can see below, all of these numbers have more than 2 decimal places. They have in fact got 3 decimal places. We need to focus our attention on the number that is in the 3rd decimal place. In this case, this number here. Remember that if it is a small number, we just leave it off. If it's a 0, 1, 2, 3 or 4, we leave it off. So in this case, we do actually leave it off, and we say that this is approximately equal to 0.47. Alright, the next question asks us to round off 0.476 to 2 decimal places. So again, we have a look at what is in the 3rd decimal place. In this case, it's a 6. It falls into that bigger category of a 5, 6, 7, 8 or 9. It's too big to just rub off. So what we do is we bump this one up, we add 1 onto that. And we end up with being approximately equal to 0.48. The final one on the page, again being rounded off to 2 decimal places, means that we have to look at what's in the 3rd spot, which in this case is a 2. It's a small number, 0, 1, 2, 3 or 4, so we can just cross it off and we'll say that this is approximately equal to 5.96. Now this is all practice at rounding off to 2 decimal places. Let's have a look now at questions where we have to round off to different numbers of decimal places. Alright, in this one the question states to round the following to the number of decimal places indicated in the bracket. So here's the bracket. So we need to round this number off to 3 decimal places. So this time we need to look at the one to the right of the 3rd decimal place, which in this case is the 5, sitting in the 4th decimal place. Now when numbers are 5 or bigger, we must bump up the one in the place value column to the left of that. So this will be approximately equal to 31.427. Note that the 31 hasn't changed, the 4 and the 2 hasn't changed. The only number that's got a possibility of changing is the 6. It might turn into a 7 or it might remain as a 6. Okay, last example here, we're asked to round off a number that we dealt with on the previous slide as well, but this time to 1 decimal place. So that means I'm going to have a look at what's in the 2nd decimal place, which in this case is a 6. Now that 6 falls into the larger category where we know that we will need to bump this one up by 1. Now when we bump up a 9 by 1, that turns it into, of course, a 10. So what will we have to do then? It will turn our 5 units into 6 units 0.0. Because our question actually asks us to round off to 1 decimal place, we do need to keep this 0 here. It tells the people who are reading our answers that we have given an answer that is correct to 1 decimal place. So just running through that again, have a look at the second decimal place. It's a 6. That means we have to add 1 on to the 9, but when we add 1 on to the 9, it becomes a 10. So we write down the 0 from that 10 and we add on the 1 here. Okay, so that's a look at rounding off numbers, and we have to round off quite a lot in real life. We round off money, sometimes to nearest dollars or to the nearest 5 cents. Now we're going to have a look at what happens when we've got decimals which keep on repeating. Okay, sometimes when we divide the numerator by the denominator, the answer keeps on repeating, and when this happens, the answer is called an infinite recurring decimal. Infinite means it keeps on going forever. Recurring means it keeps on repeating. We want to know today how to write this in a shorthand way. For example, we don't want to have to write down 0.33333 forever and ever. We want to know a shorthand way to do that. So first of all, let's look at an example that would put us in this position in the first place. If I wanted to write 7/12 as a decimal, we know that that is found by doing 7 how many 12s. We've done this in a previous lesson. So let's work out what that is by doing a division. 7 how many 12s? We know 12 won't fit into 7, so instantly I'm going to put in a decimal point and a 0 and ask myself, does 12 fit into 70? Well, it does, not quite exactly, but it does go in. 5 12s in this case are 60, but 6 12s would be too much, 72, so we have to go with 5 12s is 60. It doesn't go in exactly, so another 0. How many do I have left over from that 60 to get me up to 70? I have 10 left over. So now I have to say, does 12 fit into 100? It fits in 8 times, and 8 12s are 96, so there's still another 4 left over. So I carry that 4 with an extra 0. Does 12 fit into 40? It fits in 3 times with 4 left over. And you can see that we're starting to get a repetition of things here. 12 into 40 goes 3 times with, yep, you guessed it, another 4 left over. Now we can keep on doing this all day long, but I'm sure we've got better things to do. So how can we write that in our most shorthand way, or a shorter format? We say that this is approximately equal to, no we don't, we say it is exactly equal to 0.583, but we put a dot above the 3, and that says that that 3 is repeating. It's going on forever and ever and ever. It's a way of saying that without us actually having to write that 3 forever. Now there's a couple of other questions we're going to quickly look at. This one we also have to write using our short format. So you can see what number is repeating. The 6 is repeating. So we write it as 4.6, and to show that that 6 is repeating, we put a dot right above the 6. Our next question, 3.512512, you can hear what's repeating when I said it. 512, 512. So what do I say that's equal to? 3. What numbers are repeating? 512. I can write this in one of 2 ways. I can write it with a dot at the start and at the end of the repeating numbers, or I can write it as 3.512 with a bar across those numbers that shows that those 3 numbers are repeating. Either of those ways is acceptable. So the final one here should be pretty clear what to do. The number that's repeating, 12, 12, 12. So we're going to only write down that 12 once, and then we're going to show that it's repeating by either dots above those, or most commonly with the bar across the 12. So today we've looked at how to write repeating decimals and also how to round off decimals.